What's going on, guys? Moving on to the next question. This question is actually pretty challenging. It's one of the more difficult questions on the test. We have to show that these two brackets multiplied by each other is equal to 2 bracket A minus B. So pretty crazy question. Basically, the way I'm going to do this is I'm going to work with this left side. So I'm just going to show that this left side simplifies to 2 bracket A minus B, and then we proved it. It's just how to do this. Now notice that we have two brackets multiplying by each other, and then we have fractions that are subtracting each other inside the brackets. So what we want to do is you want to create single fractions in each bracket. Because if we can have single fractions in each bracket, we can then multiply the brackets pretty smoothly. You would just multiply the numerators, multiply the denominators when you have single fractions. And then hopefully it's going to simplify to this, 2 bracket A minus B. I'm going to try not to make any mistakes in this question. So let's go. So we got y over x minus x over y. Now we are subtracting fractions, meaning we have to get what? A common denominator. These two terms are totally different, x and y, so the common denominator is then multiplied together, xy. Now what do we have to multiply this x to get xy? We have to multiply it by y, meaning we have to multiply the top by y. So we'll have y squared at the top. And then this y we have to multiply by x, meaning we have to multiply the top by x. So this would be minus x squared. You know what? I'm actually going to write this a little smaller just in case I need more room. So y squared minus x squared over xy. Okay, so that first bracket is done. Notice that we reached our goal. We made it into one single fraction. Now this y squared minus x squared, that's actually a difference of squares. This can factor into y minus x, y plus x. But let's just leave it like that for now. If we have to factor it after, then we'll do so. Okay, what about here? We got ax plus by over x plus y minus ax minus by over x minus y. Well, notice that these two factors are different, x plus y, x minus y. So the common denominator between them is going to be these two different factors multiplied. When you have different factors, you have to multiply them. Right? So x plus y, x minus y. That's going to be the common denominator. So what did we have to multiply this x plus y by to get this? We have to multiply it by x minus y, which means we have to multiply the top by x minus y, and that top has to be in brackets. So we'll have ax plus by times x minus y. And then here, this x minus y, we have to multiply by x plus y. To get this common denominator means we have to multiply the top by x plus y. So this would be minus, there's a minus here, ax minus by times x plus y. Right? What we multiply the bottom by, we have to multiply the top by. This should actually be inside the bracket. We're just multiplying that ax minus by it, but just running out of room there a little bit. So, okay, we have now two single fractions, but notice this numerator here, we can simplify a lot further. So let's expand everything, FOIL it out, and see what happens. So we got y squared minus x squared over xy. And then let's FOIL this out. This is going to be pretty annoying. So ax times x gives us ax squared. And then ax times negative y gives us minus axy. by times x gives us bxy. I'm putting all of the letters in alphabetical order. So you could write byx here, but I'm just going to write bxy because if everything is in alphabetical order, I feel like it's easier to spot like terms. So for example, like 3bxy is a like term with 4xby, right? But sometimes it's hard to spot that they're like terms, but everything is multiplying, so you could rearrange it however. So this you could rearrange as 4bxy. Then notice they're like terms, so if they were adding, you could simplify that to 7bxy. That's why I like to put everything in alphabetical order, so you could spot those like terms a lot easier. You don't miss anything. By times negative y, that would give us negative by squared. Right? So when we FOIL this out, it expands to this. And then let's FOIL this out here. Ax times x gives us ax squared. Ax times y gives us axy. And then negative by times x gives us negative bxy. Negative by times y, that gives us negative by squared. And that's in brackets. You're subtracting that whole term there. And then this x plus y, x minus y, you know what? I'm going to keep it factored. I was going to actually expand it just to make it look similar to this, but I'm actually just going to keep this factored. It's all good. Okay, then from here, let's actually factor the y squared minus x squared. So this would be y minus x, y plus x, all over xy. And then this numerator we have to simplify. So what's going to happen here? We have to distribute the negative inside this bracket, so I'm going to actually distribute it in this line, but this would be the next line you would write. Basically, all the signs would change inside the bracket. So this would be negative, this would be positive, and then this would be positive, and then the bracket goes away, and this is minus ax squared. So that is the next line. And then you just collect like terms. Notice ax squared minus ax squared, those are like terms and they cancel out. We got minus axy. Where's another axy? Here. We got minus axy there. So that would simplify to minus 2axy. There's like a negative 1 here in front and a negative 1 in front there. So negative 1, minus 1. And this negative don't make a positive. So I meant to write the negative 1 there actually, just to not confuse you. But that negative 1 is in front of the axy. Anyway, negative 1 minus 1, that gives us negative 2. And then we got bxy plus bxy. Those are like terms as well. So that would be 2. And then negative by squared plus by squared, those cancel out. Those are gone. So we're left with this all over x plus y, x minus y. And stuff is looking a lot better now, a lot better. So now you're multiplying single fractions. You're multiplying one rational expression by the other. And to do that, let's follow our same steps. So what I'm going to do is I'm going to factor this numerator here. So this fraction I'm going to leave the same. It's going to be y minus x, y plus x over xy. And then from here, I'm going to take out a negative 2xy. What would I be left with when I take out a negative 2xy from these two? I'd be left with a minus b. And then here, we got x plus y. And notice that this x plus y and this y plus x, those are the same. They're going to cancel out, right, because you're multiplying here. But this x minus y and this y minus x, they're not the same. But we can make them the same by factoring out a negative from here. So if we take out a negative from x minus y, let's put it in front there, this would turn into y minus x. This would turn into a negative x plus y, which we can rewrite as y minus x. And then that negative I just put in front there. Okay, and now look at how much stuff is going to cancel out here. So this y minus x cancel out. Y plus x, x plus y, those are the same. this negative, those cancel out, so everything turns positive. And then this xy cancels out. What are we left with? 2 bracket a minus b, which is what we were proving. So that there is your final answer. So we proved it, took the left side, made it equal to the right side. What if they asked for restrictions on this? They didn't in the question, but let's say they did. At what point would you get the restrictions? Well, you would get them pretty much here, right? When you are actually, you know what? You would get them up there because everything is already factored initially. So you can just say when the denominator is going to be 0. So notice x cannot equal 0. Y cannot equal 0. X plus y cannot equal 0. You isolate for one of the variables, means x cannot equal negative y. And then x minus y can't equal 0, which means x cannot equal positive y. So those are the 4 restrictions, and you get them initially, because initially everything's already factored. So you could state the restrictions from there, and then we simplified. So they didn't ask for restrictions, but if they did, those would be the restrictions, and you get them initially. But anyway, took the left side, did all this crazy algebra, proved that it equals 2 bracket a minus b.